My name is Sheila Patek. I'm an assistant professor in the biology department at the University of Massachusetts Amherst. I run a lab here, and we study a range of systems, and the main goal is to link the physical principles of sound and movement with broad evolutionary questions. So one thing we like to do is to go to the field and explore the biology and the natural history of these organisms, and then also bring those animals back to the lab and apply some really high-tech approaches to studying them. Sound in the ocean is fundamentally different from sound on land. And so we go to the ocean to probe the physics and the biology of how animals communicate through the water, how they receive those signals, and how they use them to communicate with each other.
The main project that I'm currently working on falls under the Sound in the Sea research program that we have here in the Patek Lab. So I'm currently analyzing a set of sounds that we recorded at Catalina Island last March, and the sounds are produced by the California mantis shrimp, which is one of the biggest mantis shrimp. It's about this long, and it makes a very low frequency rumble sound.
The metapod is, it's a shrimp-like crustacean that has a specialized appendage that it uses to either smash on its prey or to stick out its spears and pull its prey into its burrows, which is kind of cool.
What I do here, it's mainly study the morphology of the raptor appendage of mantis shrimp. Most of the species live in the tropics, so we had to go to French Polynesia in Moorea to collect them, in Hawaii, and in Australia on the Great Barrier Reef. So those are pretty cool destinations.
Trying to measure sort of the spring mechanics of the strike of their appendage. We've been studying these animals for a while now, and it's really cool to see how different people are studying these animals in different ways and seeing how we can collaborate and find out exactly what how to solve the mystery of how these stomatopods work. This is a materials testing machine, and what it allows us to do is basically test the material properties of the spring of the appendage of the stomatopod. Basically what I do is I take the appendage and I mount them into this little rig right here, and what I can do is with this wire attached, pull on the wire, which compresses the spring, and that will give us information, will tell us how far the spring is compressed and what kind of force it produces.
I'm working on digitizing pictures of the raptorial appendage. The reason why I joined the lab was because I'm a biology major, and this lab provides me a great opportunity to join a lab and do some research.
Mantis shrimp are known to have extremely fast and extremely forceful strikes. We're measuring the impact force from these animals by using a force sensor, which we put into the water in front of their burrows, and they come out and they strike it with the end of their appendage, and then our force sensor feeds into a series of computer boards and goes into a MATLAB program where we can measure the amount of force that the animal can produce in newtons.
I like this lab because it is made up of people of many different backgrounds, and it's interesting how, although everyone is studying different things, they are able to collaborate their studies together and have a really great working environment.
One of the really fun things about running an academic research lab is that fundamentally we're here for the science. We're here to address these questions and tackle new ideas, push the field forward, explore new technology, go to new places. But in parallel with that my lab is populated with people who are students, who are still being educated, who are all moving to the next thing. So it's really fun to both probe the science world, being this team that we come together and tackle these questions. Everybody has their own angle and their own thread. They're bringing new ideas to the group, but also watching people learn and move to the next thing, and nurturing them and training them in the way that it opens new doors to them, whether it's in the science world or beyond that.